Hello. Image is not so clear. Just a minute. Camera, lights, and action. Okay, just a minute. There's no action. Before that, let me make myself a bit presentable. Yeah. Where is my... Right. Okay, I'm back once again. Where did I keep my pen? Yeah. Let me share my screen. Just a minute, guys. I think my PPT has crashed. I need to open it once again. Just give me a minute and I will open it. Right. I hope my screen is visible to you. Now let us begin with the next one. The next problem reads like this. So I hope you have watched my yesterday's video, which was on rotation. So in yesterday's video, we had seen about identifying the correct parameters needed to solve a problem, whether to use equations of motion or to find out uniform velocity. So that's what we looked at yesterday's problem. Now let us look at today's problem. Find the angular velocity of a body rotating with an angular acceleration of 2 revolutions per second square. So alpha is given to you. If it completes the 5th revolution after the start. 5th revolution after the start. So this question was given as an MCQ to my students. And when they started working on it, they saw that they used this expression, theta equal to omega I into t, because it's uniform acceleration. And hence, they understood from the previous problem, I think. Okay, so they use this, which is nothing but s equal to ut plus half at square. And they put omega I is equal to 0. Why is 0? Because it says after the start. So here definitely omega I is equal to 0. And then half into 2, what is alpha, into t square. They substituted the 5th revolution here, pi square, 25. And then they found out, okay, what is that we got? We got the value of theta from here. And then they want to find out, okay, what is the angular velocity, omega f they want. Omega f is equal to omega I square plus 2 alpha theta. Where do we get this? We get it from v square equal to u square plus 2as, right? I replace s with theta, a with alpha, u with omega I, and v with omega f. So based on this, they substituted here and got the answer as 100, or omega f is equal to 10 revolutions per second square. This is what they have got. But this is incorrect. The solution is incorrect. So where did the student go wrong? Now, if you look at this, the title says, you should be able to distinguish between time and the number of rotations. Now read the question once again. Find the angular velocity, good, omega f to be found out, of a body with an acceleration alpha as it completes the 5th revolution. Now, I did not say 5 seconds, right? I didn't say 10 minutes. So until unless that unit is not there, you should be careful. When I say 5th revolution, he is talking about the nth revolution, or is talking about the number of revolutions and not time. Now, how do we solve this? Is a bigger question. How do we solve this? So what do you think? Okay, now let me help you out with this. So therefore, now what we have theta here. And then if I say 5th revolution, okay, 1 revolution means the value of theta is equal to 2 pi radians. If I say 2 revolutions, the value of theta is 4 pi revolutions, 4 pi radians, sorry. Okay, if I say 5th revolution, that means the value of theta is nothing but 2 pi multiplied by 5. Do you agree? Right? So 10 pi radians. This is the total angle described. So you've got the value of theta. Now, why did we do this? Why did we do this? We did this because you get the value of theta here, right? You get the value of theta because alpha is given. Okay, this equation is correct, but this method is incorrect. Why did this happen? Because he substituted the value for t here, and most of them I have seen that this is what they do it here. When it say it completes the 5th revolution, they think it has already happened at 1 revolution per second. They assume it, they proceed with it. Okay, which is incorrect. So therefore, now we need to use this equation once again and write omega f square is equal to omega I square, which is 0 plus 2 into 4 pi, sorry, not 4 pi, 10 pi. 10 pi which should now be equal to 2 into 2 is 4, 4 into 10 is 40, am I right? It's 40 pi, and thus omega f should now be equal to a square root of 40 pi. Okay, which should now be equal to how much? Which should now be equal to how much? Am I doing? Are we doing right? This 10 pi. We made a mistake once again. What is the mistake? Did you point out? See, this is in radians. Okay, this is in revolution per second square. Either keep everything in revolution or keep everything in radian. Okay, that's what you need to do. So towards it, what I want to do is, let me first solve only using revolutions. I don't want to use this one also. Okay, so as a result of this, let me pull this fellow here. Right. Okay, so as a result of it, if I put just theta equal to 5 here, instead of 2 pi here, theta 5 is equal to 5, then omega f square is equal to 0 plus 2 into 2 into what is theta? What is theta then? Theta is nothing but 5 itself. 5 itself here, which should be equal to 4 into 5. That's what you get. So omega final is equal to 2 root 5. What is the unit here? Revolutions per second. Because everything is in revolution. See, I did not change this. I did not change this. If you want, you can just plug in the values also here. This is 2 revolution per second square multiplied by 5 revolutions. It will be revolution square per second square, right? I don't know whether you are getting it or not. Omega f square, the unit I am saying, this will be 2 into, instead of this 2, I will write this as 2 revolution per second square. And for this theta, this s here, theta here, I'll write this as 5 revolution. 5 revolution. Now, thus the answer that you get over here is 2 into 2, 4 into 5, 20 into revolution per second, the whole square. Okay, or maybe I will write revolution into revolution is revolution square, second square, I'll write it like this. So when you take the square, you will get this as 2 root 5 into revolution per second. So this is the right answer. Okay, so the major mistake that happened was you got confused with, the student got confused with the fifth over here, with the time over. Okay, so this is what you get. Now, if suppose in the question, if the answer that you need to answer, okay, is in terms of radians per second. Now, how do you solve with this? Now we have got omega f is equal to 2 root 5 revolutions per second. Okay, let me draw it here. So omega f is equal to 2 root 5 revolution per second. But one revolution is equal to 2 pi radians. So therefore, now this can also be written as 2 root 5 into 2 pi radians per second. And it should now be equal to 4 pi into root 5 radians per second. Right? So we have converted revolutions to radians. Now, if I ask you what is the amount of the angle, what is the angle described in degrees? Now, how do you solve this? Now, what you need to do is pi radians is equal to 180 degrees. So what you should do? You should just write 4 into 180 degree into root 5 degrees per second. If you get this value, whatever is the value you get, you can substitute it and get the answer. Okay. So therefore, this is the way how you need to solve it. I hope you would have understood this particular video, how to solve problems like this. Okay. So basically, you need to identify once again the correct amount of parameters. Okay. So once when you do this, then everything becomes easy for you. Thank you, friends, for watching this video. If you like this video, do share with your friends and subscribe to my channel. This will definitely provide me an encouragement, and hence I can put more number of videos. Thank you.